Welcome to video lecture, a course material on OML 753 selection of material by Vinod Kumar, Assistant Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Today we are going to see a topic of classification of metallic materials. A large number of metals are available in nature. They can be classified in the variety of way depending on the property. The first point is the most common way of classifying them is thereby iron content. When a metal contains iron, it is known as ferrous. The iron imparts magnetic properties to the materials and also make them prone to corrosion. Metals that do not have any iron content are known as non-ferrous metals. These metals do not possess any magnetic properties. Example includes but are not limited to lead, aluminium, brass, copper and zinc. Magnetic and non-magnetic metals. Another way to differentiate metal is by looking how they interact with the metals. It is possible to divide metal as magnetic and non-magnetic, while ferromagnetic metals attract strongly to magnet and the paramagnetic only show weak interaction. Lastly, there is a group called diamagnetic metals that rather show a weak repulsion to magnet. Iron alloy properties. All the metals have similar mechanical properties of the material, but when judged closely, one metal will have a slight edge over another in certain properties. It is possible to change the properties when creating alloy by mixing pure element. When selecting a metal for a particular application, there are quite few factors to consider to find the most suitable option. The factors include melting point, cost, ease of machining, sufficient safety factor, space available, temperature coefficient, thermal and electrical conductivity, density, etc. The Eiffel Tower is made up of rough iron. Approximately 5% of the Earth's crust is iron, thus it is an incredible easy metal to find. Pure iron is an unstable element. It reacts with oxygen in the air to form iron oxide. Extracting iron from its ore use a blast furnace. Pig iron is achieved from the first stage of the blast furnace, which can be further refined to obtain pure iron. This iron often end up the steel and other alloys. Almost 90% of the manufactured metals are ferrous metals. And then steel. Pure iron is stronger than other metals, but it leaves much to be desired. For one, pure iron is not resistant to corrosion. To keep iron from corroding, a lot of money and energy must be spent. Secondly, it is also extremely heavy due to its high density. This disadvantages can be makes the structure harder to build and maintain. Adding carbon to iron reduces the weakness to a certain extent. This mixture of iron and carbon up to a specified limit is known as carbon steel. Adding carbon to iron makes iron much stronger along with importing other great characteristics. Steel is a popular building materials thanks to its excellent properties. Over 3500 grades of steel are available today. It has high tensile strength and high strength to weight ratio. This means more strength per unit mass of steel. This allows usage of steel parts and components that are small in size. Steel is also extremely durable. This means a steel structure can last longer and withstand external factors better than other alternatives. It is also ductile and can be shaped into required forms without compromising its property. Depending upon the iron content, steel is classified into three categories. They are plain steel, carbon steel and alloy steel. Low carbon steel. Up to 0.25% of carbon in iron gives a low carbon steel, also known as mild steel. Reinforcing bars and I-beams in construction are usually from low carbon steel. Any application that requires a high amount of steel without much forming or bending are also suitable for it. Medium carbon steel. It contains 0.25% to 0.6% of carbon. Medium carbon steel application includes 1. That need high tensile strength and ductility. They find application in gearing and shaft, railway wheels and rails, steel beam in building and bridges, etc. Another use in pressure vessels. It contains cold gases or liquid because of its tendency to cold cracking. And finally, high carbon steel. The steel contains more than 0.6% of carbon is high carbon steel. This steel is harder and more brittle than the previous two. Its application in making chisel and cutting tools. Great qualities include hardness and good resistance to material wears. It may also used in pressures and for manufacturing drill bits. Alloy steel. This type of metal contains multiple elements to enhance various properties. Metals such as magnesium, titanium, copper, nickel, silicon, and aluminum may be added to different proportions. This improves steel hardenability, weldability, corrosion resistance, ductility, formability. Application of alloy steel are electric motors, bearing, heating elements, spring, gears, and pipeline. Stainless steel. Stainless steel contains high amount of chromium. This is why it has 200 times stronger than higher resistance to corrosion than mild steel. It makes it the ideal candidates to manufacture kitchen utilities, pipes, surgical and dental equipment. Also has no coating is necessary. You can have a metallic look like you want with a right surface finish. Finally, tool steel. Tool steel is used for making cutting and drilling tools. Their higher hardness makes them an ideal choice for those applications. They contains molybdenum, vanadium, cobalt and tungsten as a constituent metal. Thank you.